So I want to talk to you about trigonometric substitution. There are times that you see some integrals such as, let's say, 3 over square root of 1 plus 9x squared dx. So you look at this and you try use substitution and stuff like that, and you realize, goodness, yeah, nothing is really working, and I really don't want to use a calculator. But you keep looking at this and you realize that, this denominator right here, it reminds me of a right triangle. So let's say that if I have a right triangle and this, let's call this angle right here, x or theta. And so this, let's say, call this A1, and let's call this one, let's say 3x. So you know that the size of this hypotenuse is square root of 1 squared, which is 1, plus the square of the other leg, which is plus 9x squared. And you wonder to yourself, can I somehow relate these two things together? And the answer is yes. In fact, there are going to be three scenarios that we are going to be seeing in this section, trigonometric substitution. One scenario is that you are going to have, let's say, some integral involving, I'm going to say involving some a to the second, like some number to the second, minus x squared. And if you see something, a number in here, minus a variable x to the second, this should remind you of sine of x or sine of theta. So in this case, you use, let me actually just write it in a cleaner way. So if you see square root of a squared minus x squared, then use x equal sum a sine of theta. If your integral involves square root of a squared plus x squared, okay, then use x equals a tangent of theta. And finally, if the third case scenario, if you see square root of a squared minus x squared, okay, then use x equals sum a secant of theta. So these three are the different case scenarios that we're going to be using in this section. Now let's do just a couple of examples, let's do a couple of examples. Suppose I have, what was the example that I just talked about a few minutes ago? Yeah, integral of 3 over square root of 1 plus 9x squared dx. Okay, so let me draw a right triangle in here. So my theta being in here, this is a 90 degrees. And so let's say if I put this a 1 and if I put this 3x, so I know that the hypotenuse has to be square root of 1 squared is 1 plus 3x squared is 9x squared. Okay. Now using that triangle, and for me, it's just best to do the triangle right on the spot, the first step. You don't have to, but for me, it's helpful. So here I'm going to just say that since I do have 1 plus 9x squared, so I'm supposed to use this is the form of, this is the form that I have square root of sum a squared, which is 1 squared. It's just 1 plus x squared. So I'm supposed to use x equals sum a tangent of theta. Tangent of theta. So I just wanted to show you that. All right. So now I'm going to go ahead and say that the tangent of theta equals 3x. So here's, or you can say 3x or 1. Look at here. Tangent is, here's your theta. Tangent is opposite over adjacent, so 3x over 1 or 3x, okay? So if tangent of theta is equals 3x, then we can say that theta equals 1/3, okay? Or let me say one more baby step here. Say that x equals 1/3 tangent of theta. So if tangent of theta equals 3x, then x equals, multiply both sides by 1/3. And so now from here, I can say that dx equals, I can claim that dx equals 1/3 secant squared of theta d theta. So, all right. So now and notice that here, I can replace dx with all this in here. So let me go ahead and go to the next page and continue. We had integral of 3 over square root of 1 plus 9x to the second dx. This is what we originally had. And so now let me exchange that. Here's my 3, okay, over square root of 1 plus 9. And we found that x equals 1/3 tangent of theta. And so here's x squared. And what was dx? We said dx is going to be 1/3 secant squared of theta d theta. So now I'm ready to continue. Notice that this equals integral of this 3 times 1/3 is just 1. So I can put the secant squared of theta in the numerator. And the denominator, and here's of course my d theta from here. And in the denominator, I can get square root of 1 plus 9 times 1/3 tangent of theta's quantity squared is 1/9 tangent squared of theta. Okay, so of course now notice that I can cancel this 9 with this 1/9. So this equals integral of secant squared of theta over square root of 1 plus tangent squared of theta, and here's my d theta. And remember that 1 plus tangent squared of theta, okay, let me go to let me go to the next page. So I have 1 plus tangent squared of theta, and that would be what? Secant squared of theta. So I'm showing every step there is. So this equals integral of, on the numerator, I have secant squared of theta, and I have the d theta, then I have square root of, I have, excuse me, square root of 1 plus tangent squared of theta, which is secant squared of theta. And now this equals secant squared of theta over, I have secant squared under square root. It cancels with the root. So I'm going to have secant theta d theta. And notice that this nicely turns out to be integral of secant of theta d theta. And in the past, we showed that the integral of secant of theta equals natural log of absolute value of secant theta plus tangent theta plus c. Now, we are not done yet. We have one more step because we started with x. So we have to exchange these thetas in here with x. So how do we do that? Let me go to the next page. So far we left off as natural log of absolute value of secant of theta plus tangent of theta plus c. So how do I change the theta back to x? I'm going to use my triangle again. So remember that in the triangle in the very first page, this was theta, 3x was here, 1 was here, and this was square root of 1 plus 9x to the second. All right. So that equals natural log of absolute value of, what is secant of theta? Secant of theta is 1 over cosine. So it's going to be absolute value of square root of 1 plus 9x to the second plus 3x. So what is tangent of theta right here? Is opposite or adjacent. 3x over 1 is 3x. So plus 3x, close absolute value, and plus some constant c. Okay. All right, let's do one more example. I think we have time to do one more example in this video. Let's go. Let's do this time something that we can use, something different than tangent. So how about integral of 5 over, let me have square root of 25x to the second minus 9 and dx. And so notice here that I can't have 0 in the denominator. And of course, under square root, I cannot have negative. So 25x square root minus 9 has to be greater than 0, not even equal to, because it's in the denominator. So 25x squared, it has to be greater than 9. X squared has to be greater than 9 over 25. So take square root of both sides, and so you get 3/5. So with the understanding that, let me put it in red here, all this in taking integral of this, with the understanding or stipulation that x has to be greater than 3/5. Okay, so let me erase this. Okay, so now let's do the triangle. Put the, here's my 90 degrees, put the theta here. And since I do have 25x squared minus 9, so let's call this 3, put this 3 here because square of that is 9. So call this 5x, and so this side will become 25x squared minus 9. I hope you see that. 25 squared minus 9. I hope you can read my handwriting. Okay, once again, this right here is 20 square root of 25x squared minus 9. So let's set secant of theta equals 5. So from here, we want to use secant of theta. So what is secant of theta equal to? Secant is 1 over cosine. So I have 5x over 3. And so this tells me that x equals 3/5 secant of theta. Well, if that's the case, what is the dx? Then dx equals 3/5 secant theta tangent theta d theta. Now I'm ready to use this dx. So the next step, I'm going to say that this integral equals integral of, on the top, here's my 5. Instead of dx, I have 3/5 secant theta tangent theta, and let's put the d theta in here. It doesn't matter, or just put it up here. It really doesn't matter. It really doesn't matter. Tangent theta d theta. All that divided by square root of, here's a 25. We said that x is 3/5 secant theta, 3/5 secant theta, and that was squared, minus 9. Okay, very nice. Now let's go to the next page and simplify some stuff in here. So this 5, of course, cancels out. Okay, and I'm going to just score this term right here. Let me go to the next page. So that equals integral 5 times 3/5, of course, is going to give me 3 times secant theta tangent theta, and let me just d theta all over. We had in the denominator square root of 25 times 3/5 squared is 9/25 secant squared of theta. Let me just, and then I have a minus 9 in here. All right. So if you feel better, put the d theta in front. It's the same thing. All right. Now notice that I can simplify this 25 with this 25. All right. So let's just do that. So this equals 3 times secant theta tangent theta. Here's the d theta all over square root of 9 secant squared of theta minus 9. Very nice. And so notice that now I can factor out 9 from the denominator. So this equals 3 secant theta tangent theta all over square root of 9 times secant squared of theta minus 1. Okay, and I have a d theta in here. And now I can bring that 9 out. Okay, so I 9 under square root is 3. So let me go to the next step, next page. So say that this equals 3 times secant theta tangent theta d theta over 9 under square root is 3. So 3 outside, and then I have square root of here. What's secant squared of theta minus 1? Secant squared of theta minus 1 is tangent squared of theta. Yes, tangent squared of theta. So tangent squared of theta. Okay, very nice. And so, of course, now I can cancel 3 with 3, and I can cancel this with this. So one baby step, that equals, let me change color, secant theta tangent theta over tangent of theta d theta. And now nicely I can cancel this with this. And we proved before that now the integral of that is going to be natural log of absolute value of secant theta plus tangent theta plus some constant c. And one last step, again, we have to convert this theta back to x, otherwise we're not done. So remember that in the beginning, we had a triangle like this, theta 3, this was square root of 25x squared minus 9, and this was hypotenuse was 5x. And we left off at natural log of, let me put the equal sign, natural log of absolute value of secant theta plus tangent theta plus c. So this equals natural log of absolute value of, what is secant of theta in here? Secant is 1 over cosine. So I have 5x over 3. And then I have plus tangent of, what's tangent is opposite over adjacent. So I have square root of 25x squared minus 9 all over 3, and all that plus c. Okay, so that is the final answer. Okay. All right, we'll talk soon. Thank you.